Hello, we're now going to start talking about model building. Before we go into that real quick, let's talk about a few things we have to take into consideration. First is data consideration. Our dependent variable, which is the rate of enrollment in primary school, is a continuous variable. Each country can have anywhere between 0 to 100% of a rate of enrollment. And for that reason, because it's a continuous variable, we ruled out logistics regression. Also, all the data is linear, and for that we chose because of that we chose three different models. We're going to utilize linear regression, and neural networks, and then all the variables in our independent variables are continuous. So we broke them up into categories. It's sort of a low, medium, high type of scenario. We're going to talk about that here in more detail here in a little bit. Um, a few exploration issues we ran into. The data set values had some no values. We changed the storage type to continuous, changed it to blank, so the storage type was changed to continuous. And in our dependent variable, we had some no values in there, which were causing errors in R. We changed those to NA to perform the descriptive statistics. All right, and here we have the results of our descriptive statistics on some of the more significant variables. On top here, we have adjusted the adjusted enrollment rate for primary school. You can see what the mean is, 91.25, and the median is 95.235. You can see the minimum value, the maximum value, the variance, and the standard deviation. See a few other things. And then we have four of the independent variables in here. As you can see, they also each have a mean, median, minimum value, variance, maximum value, and standard deviation, as few as other figures in there. This is a little bit more detailed descriptive statistics for one of the variables, which is expenditures on primary education as a percentage of total government expenditure. As you can see over here, the values almost form a bell-shaped curve. It's, if anything, it's a bell-shaped bell. And then over here you have some of the statistics as well: the mean, the minimum, the maximum, and the standard deviation. We verified our descriptives utilizing R. So as you can see over here, for each of the variables, we have things like a minimum value, the median, the mean, the maximum value, um, for each of the different variables. All right. Now, we mentioned this a little bit earlier. Since all the variables and the independent variables were continuous, such as, for example, in this case is the GDP per population, we categorized them into 6 levels. So you have poor, low, medium, high, and super. And as you can see, as the GDP per population increases, so does the enrollment rate, with it topping off with the high and the super high. We also put the data into the Power Pivot to do an analysis on adjusted enrollment rate for primary education. Um, I will show you that screenshot here in a bit. Certain independent variables we found out are inversely proportional to the adjustment enrollment rate. Alright, and this is the screenshot I just told you about. Some of the independent variables that we found out were inversely proportional. One is repeaters of primary of all grades. Another one was the cumulative dropout rate to the last grade of primary education. So those two, are pretty are pretty easy to understand. As kids drop out or have to repeat grades, there is obviously those two um, occurrences are have a inverse relationship to the enrollment rate. Obviously, the more kids drop out, enrollment rate gets slower. One that did kind of surprise us a little bit is that its expenditure on primary education as a percentage of government expenditure on education, according to the statistics, would also inversely proportional to to the enrollment rate. So the more the government spent on primary education as a percentage of a total expenditure on education, the lower the enrollment rate got. All right, in building the actual models, we utilized IBM SPSS Modeler for all three. The first model we utilized was linear regression, and that model gave us 89.6% accuracy. And the most important factor was the repeaters of primary school for all grades. The second model was a neural network. That model summary gave us an accuracy of 98.3%. And the most important predictor was expenditure on primary education as a percentage of government expenditure on education. The third model was regression. And that most important predictor was also the expenditure on primary education as a percentage of government expenditure on education. Now, the regression equation we got is this is here. As you can see, the enrollment prediction rate is determined by various variables. Each one has a different coefficient. In this case, I've highlighted the cumulative dropout rate. As you can see, it's a negative coefficient because it has, I spoke earlier, an inverse relationship with the target variable.